Welcome to the webinar conducted by Pristine on hypothesis testing using various tests. So first a brief introduction about Pristine. Pristine is a leader in trainings for finance, and it is authorized by the CFA Institute, GAP Institute, Premier Institute. So basically it has got that first a brief introduction about Pristine. Pristine is leader in training for finance. It is authorized by the CFA Institute, GAP Institute, Premier Institute. Pristine has got the experience in serving a marquee client list, which includes Bank of America, JP Morgan, Ernst & Young, IIM Calcutta, and National University of Singapore. So the topic covered today would be hypothesis testing. We'll cover all the basic concepts in this topic. We'll primarily focus on one-tail test and two-tail test, confidence interval, significance level, p-value, and the chi-square test. So all these are very important as the CFA and FRM exam concerned. We can expect around 2 to 3 questions in the exam from today's discussion. So first of all, let me brief about hypothesis testing. You can think of hypothesis testing as consisting of 5 simple steps. It is very hypothesis. So in this, you need to understand the difference between null and hypothesis. Maybe after formulating the hypothesis, the second step would be choosing the appropriate test. So the 2 factors should be considered while choosing the test. It should be based on the sample size and the nature of underlying distribution. We'll see which test to use based on different sample sizes and based on different nature of underlying distribution. It is normal distribution or non-normal distribution. After choosing the test, we have to determine the test statistics. So every test has a formula for test statistic which we will use, and we'll use that to get the appropriate test statistic. So once we have determined the test statistic, we have to find out the critical value. The critical value will be determined based on level of significance. So critical value will be determined based on the level of significance and the test we have chosen. After we have determined critical value, we have to apply the decision rule. So the decision rule would be very simple. It will compare the test statistic with the critical value. So for example, if you have got a certain test statistic, you are using a test or a test, so you will compare that test statistic with the critical value of that test, and then we will arrive at a decision whether we have to reject the null hypothesis or accept the null hypothesis. The decision in terms of hypothesis will always be taken in to reject the null hypothesis or we are going to accept the null hypothesis. So the null hypothesis is the hypothesis which we want to reject. It generally takes equal to sign. For example, if we take suppose we wish to challenge that the mean acceleration due to gravity is not 9.8 meters per second square. In this case, our null hypothesis would be like acceleration due to gravity equals to 9.8 meters per second square. So it is basically representing the status quo which we are having at the moment. And our alternate hypothesis will represent a hypothesis in which we believe in which we think we have certain data to back it up with. So moving forward, now we'll discuss about we'll try to understand what is the difference between one-tail test and two-tail test. So a two-tail test will generally be of the form your null hypothesis is mu equal to mu naught, and your alternate hypothesis is mu not equal to mu naught. So basically in two-tail test we are considering both sides of the distribution. So the side which lies to the left of the mean as well as the side which lies to the right of the mean. So in this diagram, as you can see, this is a two-tail test, and we have this shaded region actually represents the region in which the null hypothesis can be rejected. So if the significance level is 5%, it will be distributed equally in this region, right, and in this region. So the important thing to note is that the critical value for a one-tailed test and two-tailed test will be different at the same level of significance. For example, in this case, it is a Z distribution, and we are taking 5% level of significance, and the critical value is different for both a one-tailed test and a two-tailed test. So for as you can see, in a one-tailed test, the critical value is 1.645, and in two-tailed test, the critical value is 1.96. So obviously the absolute value in a two-tailed test is greater than absolute value in a one-tailed test. Now moving forward, now we'll try to understand what significance level actually signifies. Significance level, the best way to understand significance level is to think it in terms of the region of distribution it stands for. For example, in this case, if the significance level is alpha, then if it is a two-tailed test, then this alpha will be the region, percentage of the region in the distribution where we can reject the null hypothesis. So since it is a two-tailed test, the region will be divided between two regions. One is to the right of the mean, that is this region. So alpha by 2% of the region will lie here, and alpha by 2% of the region will lie here. So in this region, we can actually reject the null hypothesis. So this line will actually, this line which have been drawn here, let me do this full screen. Okay. So this line actually represents the boundary of the region. So this will give one critical value will define this region, and the second critical value will define this region which lies to the right hand side of the mean. So the important thing to note is that the critical value is actually defining the region in which the null hypothesis can be rejected. So in a two-tailed test, you will have two critical values. So as we increase our level of significance, the chances of null hypothesis getting rejected will be higher. So this can be understood by noting the fact that as we will increase the level of significance, this region will actually expand both sides. So if at the moment our alpha is 5% and suppose we are going for an alpha of 10%, so this region will actually expand. So the region in which we can reject our null hypothesis, that is this region, will expand. So now we have learned the concepts, and we can discuss the first question of our quiz. I have already mailed you the questions. So once again, if you can go through this question, and if you are you can also type in your responses in the chat box. Let's see who gets this first. Okay. Right. So someone, yeah. So it's okay. So Matthew has got it right. He says the answer is 1, and the correct answer is 1. Let me tell you how he has arrived at this solution. So the question they ask us is a very simple question. It says that which one of the following 4 statements about null hypothesis testing, this is irritating, right? So the question is which one of the following 4 statements about null hypothesis testing holds true if the level of significance decreases from 5% to 1%. So we are decreasing the level of significance. So as I have already discussed, if we decrease our level of significance, the region in which we can reject the null hypothesis will shrink down. So if you are decreasing from 5% to 1%, the region in which our null hypothesis can be rejected will be decreased from 5% to 1%. Hence, by going through the option, we can see that the option A is the correct answer. So now moving forward, we'll discuss the concept of confidence interval. So once again, we'll try to understand confidence interval in terms of the region bounded by the confidence interval values. So confidence interval will actually define two values which will bound our distribution, right? The percentage of area which will be bounded by the value defined by the confidence interval will be 1 minus alpha. Alpha is here our level of significance. So this is so this value is actually the complementary of the value of alpha. So if your confidence interval defines the region, I should say bounds the region in which we can accept the null hypothesis. So the region bounded by these two lines is equal to 1 minus alpha % of the region of the distribution. So how confidence interval are actually constructed? It is constructed by adding or subtracting an appropriate value from the point estimate. So point estimate is your population parameter, which can be your mean or standard deviation. So if you have to evaluate, okay, I should say calculate the confidence interval. So you have to add and subtract a certain value from the point estimate, and that value will be equal to this critical value, which will explore what it is actually, multiplied by standard error. So both the terms will be described now. So the critical value. So the critical value is also related to your level of significance and the type of distribution which you are following. So critical value is a very important value because our decision to reject or accept the null hypothesis will ultimately depend upon the critical value. So suppose our level of significance is alpha. So we'll use that value and we'll look up that value in the type of test we are using. Suppose we are using Z test. So we'll look in the Z table. We'll also look at the level of significance and we'll get a value that is critical value. No, standard error. So standard error is the standard deviation of the distribution of sample means. So what we actually mean by distribution of sample means is that suppose that you have a very large population and you take a sample of size n from that population. So you can have various such samples of size n from that population, and each such sample will have its own mean. And the mean that you will have its own distribution. So the standard deviation of that distribution is actually your standard error. Okay, so let me once again repeat it. Suppose that you have a very large population and you take a sample of size n from that population. So each sample will have its mean, and that mean will be different from the other sample of the same size n from the same population. So those means will have a distribution of themselves, and if we'll find the standard deviation of that distribution, we'll have standard error. So Standard, if your population standard deviation is known, then your standard error is very easy to calculate. It is equal to standard deviation of the population divided your square root of the sample size, which is n. And in case you don't, it's because it's very difficult to know the standard deviation of the population because the population size is very large. So to save ourselves from doing that, we can take the standard deviation of the sample as an approximate measure of the standard deviation of the population. So in that case, our standard error would be the standard deviation of the sample divided by the size of the sample under root. So now we can attempt our second question. Second question is like the average return of a sample of 49 stock is given. It is 7.4%, and sample standard deviation is given to be 5%. Okay. So the sample standard deviation is given to be 5%, and we have to construct a two-sided 95% confidence interval for the population's true stock return ratio. So we'll be using the same formula which I have discussed right now. But the important thing to look in this question is to decide which test or which value we should take, whether to use the t-test, z-test, or any other kind of test. So since the sample size is large, if the sample size is greater than 30, we consider it to be large. So in that case, we can safely use the test if we don't have information about the non-normal distribution. Since the sample size is large for 49 observations, we can safely use the z-test. So here, since it's a two-sided test, so we have to use critical value, which will be by alpha by 2. So here z has the critical value, which we have to look in the z table. This term is your standard error. So your standard error here is by root n, which is standard sample standard deviation is given to be 5%. And so if you put all those values, right, so 7.4% is your average, is your mean, and your critical value will come, since it is a two-sided test with 5% significance level, your critical value will come to be around 1.95, which you can verify by looking in your Z table. So the answer will come to be, correct answer is answer option 2. Now p-value. Let us understand what is p-value. P-value is very important concept in hypothesis testing, and so p-value gives the smallest level of significance for which our null hypothesis can be rejected. So suppose we have a two-tailed test with test statistic equal to 2.1. So how we can find our p-value? So the important data we have is the test statistic. What we need to find p-value is test statistic. Our test statistic is 2.1. Since we have to reject the null hypothesis, we have to look for region in which we can reject the null hypothesis. So our absolute critical value should be less than the absolute test statistic. So in this case, our critical value should lie between minus 2.1 to 2.1 because we have to reject the null hypothesis. So the null hypothesis can only be rejected if our p-value lies between minus 2.1 and plus 2.1. So if we look up in our cumulative Z table, we find that the area covered till the value 2.1 is 0.9821. Hence the probability of getting the value greater than 2.1 is 1 minus 0.9821, and that is equal to 0.0179. Since it is a two-tailed test and a normal distribution is symmetrical, the probability of null hypothesis being rejected is equal to 2 times this value. which is represented by the region, this region which is colored. So the p-value will be 2 times this value. So some of our attendees have actually asked me to once again go through this concept of p-value. I'm doing that. So the important thing to understand is that the p-value represents the smallest level of significance for which we can reject the null hypothesis. So our test statistic is given to be 2.1. And since we have to reject the null hypothesis, our critical value should be less than this value of 2.1. Then only we can reject the null hypothesis. So when we look up in cumulative Z table, we find that the area covered till the value 2.1 is 0.9821. So the area we need to consider is the value which lies to the right of 2.1, which is 1 minus this value, which we find after looking in the cumulative Z table. So this value we got as this much. And since the normal distribution is symmetrical in nature, the p-value will be 2 times this value. So if our p-value is 3.58%, which means that we can't reject our null hypothesis at significance level 3%, which is lower than our calculated p-value. So in this case, our p-value has come to be 3.58. So if we have a significance level of 1%, which is lower than our p-value, so in that case, we can't reject our null hypothesis. So this is an important thing to understand here. So now we'll move forward, right? So when to use Z-test? We'll use Z-test when the population follows a normal distribution or the sample size is very large. As I already told you, if the sample size is very large, we can use our Z-test. So, and if the population variance is known. So the two important criteria which we should look before using Z-test is that whether the population is following a normal distribution or whether the sample size is large. And the second criteria is whether the population variance is known or not. If the population variance is known, then and the population follows a normal distribution or the sample size is large, we can use Z-test. And the test statistic is given by this following formula, which is x minus x is your value which is to be tested, minus mu divided by sigma upon root n. In case of t-test, the important thing is that the population variance, it is a mistake here, I made a mistake here. Population variance is not known in the case of, let me rectify it. Population variance is not known. So in the case of t-test, the population variance is not known and we use the standard deviation of sample in place of standard deviation of the population. So this formula is basically very much similar with this one. We just replace the sample, standard deviation, so now test of variances. So it's a better idea to use chi-square test when we have to use when we have to test variances of a normally distributed population. So in that case, our null hypothesis would be like uh, our variance is equal to variance not square. So the test statistic in a chi-square test is given by the following formula. We use the sample variance in our formula and also the hypothesized value for the population variance. As we have done in the t-test and z-test, we'll do it in a similar fashion. We'll compare the test statistic with the critical value at a given level of significance and n-1 degree of freedom. So degree of freedom is calculated by the value by the sample size. So if your sample size is n, your degree of freedom would be n-1. So we can see this from the following question, right? It's basically an application of chi-square test. So I've already revealed the answer to you. Okay, so we have this ABC equity fund, and it believes that its monthly returns have a standard deviation of 4%, and this is based on the estimates from 2000 to 2010 period. So ABC equity fund collects monthly return for the 24-month period between 2010 to 2012, and it measures standard deviation of monthly return to be 3.8%. Which test is to be used and what is the test statistic? So the options are, first we have to decide which test we are going to use. So the option given is either chi-square test or the F test. It's important to note that the F test is also used to compare variances but of two different populations. So in this case, we have only one population, so we won't use F test in this case. We'll use chi-square test. Now we have to calculate the test statistic. All right. So as we have seen that the test statistic in a chi-squared test is given by n-1 into s square divided by the hypothesized value of variance. So in this case, n is the sample size, which is 24. So n minus 1 is 23. The sample variance s square is 3.8, and since it is in the form of percentage and squared. And your sign sigmatized over and squared. So if we plug in these values in this formula, we get 20.5 as our answer. So that answer would be option A. So move forward, we have got one question. It deals with a p-value, which I have already explained. So in this question, we have been given the test statistic, which is 1.9, and we have to options are given in terms of p-value. So we have to first find out what is our p-value. So for this, I have the t-table is 1. Since we are using t-test, so this is the t-table. So the sample size is 30, so the degree of freedom would be 29. So our test statistic is 1.9, which is falling between these two values, 169.04. So since this is a test, we have to see the values which is the capability. So it tells us that p-value lies between 0.05 and 0.05, right? Which is option B. So you also will get the PR correct. C is correct. So p-value lies between 5 and 0.5. So when p null hypothesis, p-value gives the minimum significance level at which we can reject our null hypothesis. But if our p-value is greater than 0.025, we can't reject the null hypothesis at a significance level of 0.025, right? So this was a basic idea about hypothesis testing. I've gone through all the important questions. If you have any queries, you can drop me a mail at my ID, which is divyank@enev.com. You can also go through the following blogs, which can be useful for your CFA/FRM preparations. We'll be conducting similar webinars, the registration link for which has been given in this PPT. I'll be mailing you this PPT. You can check it out. You can register yourself to the future webinars, which is scheduled in the next week, right? You can also mail your questions or any doubts about your FRM and CFA examination. So we have a classroom training coming soon in New York. Okay, we'll have a crash course for FRM preparation just before the FRM examination. So if you are from New York and if you are looking for a crash course, so you know where to go, right? So this ends our webinar. Looking forward to your presence in future webinars.